Okay, so we got number 7, which says we got this funky curve, 3 cosine of x cubed over 4. So I graph that, and I get this horrendous thing, and this is in zoom 4, and I'm in mode radians, so that if in case you're not getting it to look like that, it looks like it goes through plus 3, which makes sense, amplitude of 3, but it does crazy stuff since it's x cubed, but it crosses just before 2. So I'm going to draw just that part because that's what they asked us to look at. Goes through 3, and just before 2 it comes down. And they're talking about this region in the first quadrant, and stops at the first positive value of x where the curve is 0. Okay? So what is this point? That's the one thing I want to find out. So I'm going to go to second, calculate the 0, enter, and it's between 1 and 2. 1, enter, 2, enter, and it says, what's my guess? I'm going to say 1.9, and it says, no, you silly, it's 1.8452, 1.8452701. 2701. I don't know if I'm going to need that much accuracy, but just in case the book wants that accurate, I'll put that in. In fact, that is my x value. You notice if I go quit on my calculator and type in x, enter, I get that number. So I can store that in A. So I've got that hanging around. That's in A now. Okay. Now the first thing they ask for, part A of 7, is to find this arc length. How far is it from there to there? And that formula, remember, was the square root of 1 plus the derivative squared dx, and evaluated from whatever x needs to go from. And so that's from 0 to this. So we need the derivative of this. So the derivative of cosine of something is negative sine of the something times the derivative of the inside, which is going to be times the derivative inside, which is going to be 3x squared over 4. There's the derivative. So here we need to do clear square root of 1 plus this derivative, and I got to square it, so I'm going to put a parenthesis of negative 3, which is not going to make any difference because I'm squaring it, sine of x to the third divided by 4, close parenthesis, times, come out of the square root, 3x squared divided by 4. Close the parenthesis. Oh, and it stopped my square root. I didn't want it to stop my square root. Let's go back here. It shouldn't have. So how do I make this work? Let's go back here, delete the square root, and insert a parenthesis, and that way I'll make sure I get it all. To the 0.5. No. That's the square root, but then I need to get all that derivative squared. Okay, let's get this straight here. 1 plus, there's 1, 2, 3 openings. 1, 2, squared it, and then open. So I got to go to here, and second insert another parenthesis. So that parenthesis goes to there, and that's the derivative. That's got to be squared, and then take the square root of all of that. There we go. I finally got it all in there, I believe. So second calculate 7 it's something crazy strange, but I need the integral from 0 to that number. So 0, enter, and since I stored it in A, I can go alpha A, and that'll put that number in there. Went from 0 to 1.45, and it came up with an area, or an arc length, the area is the arc length, of 4.105 2, blah, blah, blah. That's approximate. So there's the arc length. That's kind of a mess to put into the calculator. Set up a different integral whose value is the exact area of R using technology. So the exact area of this region would be simply the integral from 0 to that same number of this curve. 3 cosine x to the third over 4 dx. So that's a little simpler. Clear 3 cosine x to the third, come down, divided by 4, close parenthesis. Second calculate 7 from 0 to alpha A, and that is 4.6623. Okay? And C. Suppose the region is revolved around the x-axis. Set up a definite integral and use the exact volume of the solid. So now we're going to go around the x-axis. So if I use a disk method, which would be pretty simple, there's no hole in this, I'm going to slice vertically. So it's going to be pi radius, and the radius is going to go from 0 to up to here. It's the y value, and the y value is this, 3 cosine x to the third over 4 squared dx, because the thickness of it would be dx. This is in terms of x. Evaluate from 0 to that number again. So now I just got to go back and square this, and then take my answer times pi in the end. So I'm going to second insert a parenthesis, and then go to the end of this, and close parenthesis squared, and second calculate 7. Now I can't even see the top of it, but I don't care. And my lower limit 0, enter. My upper limit is alpha A. Good thing I stored that in A. And that comes out to be 12.834144. 12.834114 pi. And that's actually, if you wanted, just so you know, variables, let's see, function variables, do I have that in here? Nope, I don't know where that is. I've forgotten where that is. that's stored somewhere. But anyway, I would take that second quit 12.834114 alpha pi, and I get 40.31955 blah 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 blah. Okay? And D. Suppose it's revolved around the y-axis. If possible, set up an integral expression whose values is the exact volume of the solid of revolution. Evaluate the integral approach. If not possible, explain why. Okay, so now we got to take this around the y-axis. So if we try to do a disk method like the only method they give us, we're going to have to solve for this. We'd have to solve this for x, which is not so easy. Let's see what we would have doing the disk method. I could have done shell method on this other last one too, but let's go to the disk method on this. So it'd be pi integral from 0. Okay, so the thickness now is dy. So what's y go from? 0 to 3. And the radius squared is x. So we have to solve for x. So if y equals 3 cosine x to the third over 4, I divide by 3. Take the arc, the inverse of cosine, which is arc cosine, or cosine inverse of this. Gets rid of that. Then I'd multiply by 4, and then I'd take the cube root, and then I'd square that. So I'd have pi integral from 0 to 3 of, so that's 1/3 squared is 2/3. So 4 cosine inverse of y over 3, all of this to the 2/3 dy. And I think we can do that. Let's see what happens here. So now we're doing 4. Oh, better start off with a parenthesis because I got to put some powers on this. Now let's just clear it off. Parenthesis. 4 cosine inverse of x divided by 3, close parenthesis, to all of this, close parenthesis, to the 2 divided by 3. Come down. Second, calculate the area from 0 to 3. Looks like it's going to end at 3. 0, enter, 3, enter. And it says it's 7.4141126. Pi times 7.4141126, which is 7.4141126. Pi is 23.2921 blah blah. Let's do this one with shell. So then I would still slice it this way, and I mean not shell but ring. There is a method called shell, but we're not going to study that one. So the slice thickness would be dx, so I can use things in terms of x, and it's 2 pi integral. X is going to go from 0 to that strange number we had up here with the 1 point, which is still in my A, of pi r, 2 pi r. The r is going to be the x, and I'm in the x direction, so I can just put x. And then the height is y up to the curve, but y up to the curve, but y is this, so I'd have times 4 cosine of x to the third over 4, and that's it. And this was a lot easier to do than that one. We didn't have to go through all that messy stuff. And so, oh boy, oh boy, oh boy. No, I think I did that right. Yeah. Okay, so clear this. So it's x, then parenthesis 4 cosine x to the third divided by 4, close parenthesis, and then I can take it times 2 pi, or I can do that at the end. I'll put the 2 pi right here, 2 pi, so putting the 2 pi back in, and graph. And I want to find the area. Second, calculate 7 between 0 and that A that we had before, which is, I got stored in A. And it gives me, since I already put it in there, I get 31.055. 31.0559. I missed on this. What did I mess up here? So r is x, the height is this, times 2 pi from 0 to a. That's correct. This is 0 to 3 dy of that of x squared, and x, let's see if I did this right. So divide by 3 to get that out of there. Do the cosine inverse of y divided by 3, and then that would leave x to the third over 4, multiply by 4, and then take the cube root, and then I've got to square this. Cube root is 1/3, squared is 2/3. 4 cosine inverse y over 3 from 0 to 3. Clear. 4 cosine inverse of x divided by 3, close parenthesis. All of this, so I got to go parenthesis here, go back and put a parenthesis at the beginning. Second, insert a parenthesis. All of this to the power 2/3 to the 2 divided by 3. That's all of it. And then I'll put the pi in there. Oop. Second, insert alpha pi. There we go. So now I've got the pi in it, so I should get, I don't have to do this part, should get the right answer here. Let's see. Second, calculate 7, so it'll draw the graph. And I want to calculate the area from 0 to 3. 23.29. I'll have to think about this one. Why isn't that working? Might be something to do with taking the inverse of this. Not sure. Wonder what the answer is. Let me check. 7. Got to come over here. Six, 2, problem number 7. 23.29. This is correct. I made a mistake on this one. All right. So let's see what I did wrong here. So if I'm doing this, the thickness is dx, the height is y, and y is, oh, there's my mistake. It's 3, and I put a 4. There's the mistake. Ah, okay. Clear. 2 pi per x, close parenthesis, open parenthesis, 3 cosine x to the third, come down, divided by 4, close parenthesis, and that's it. Yes, close parenthesis, and second, calculate, 7. And I'm going to go from 0 to 3, and what did I do wrong? Oh. Got something wrong in there. 2 pi x 3 cosine x to the third plus 4. All right, divided by 4. X to the third divided by 4, close parenthesis. Oh, 0 to a. That's what's wrong. Got confused with 0 to 3 there. Boy, I'm making a lot of mistakes on this one. Okay. Second, calculate 7 from 0 to alpha a, which should be just this first part and not over in here. And that does give me 23.291. 23.291. All right. I miswrote the 3 as a 4, 4 as a 3. That should have been a 3. And it should have been to A. So there it is correctly. This is actually a lot cleaner to do with ring than this was, except I made a mistake. A couple mistakes. All right. That was 7.